Hello everyone, welcome to all in this lecture. So in the previous two lecture, I have discussed some GATE previous year questions. So total I have discussed 17 questions. So in these questions also I am going to discuss some more numerical problems, previous year GATE questions I'm going to discuss, and that is based on the bearing capacity of soil topic. So let's start. पहला क्वेश्चन है हमारा, आप देख सकते हैं. So the ultimate bearing capacity of a soil is given 300 kilonewton per meter square. The depth of foundation is 1 meter and unit weight of soil above the water table is 20. Factor of safety is given 2.5. So we have to calculate net say bearing capacity of soil, that is QNS. And what is QNS? That is equal to QNU divided by factor of safety. And what is QNU? Net ultimate bearing capacity of soil, that is QU minus overburden pressure, gamma dF. So we have to reach from here to here, there. Okay. So in the question, you can see Q is directly given, depth of foundation is given, factor of safety is given, and this water table. So unit weight of soil above the water table is given 20 kilonewton per meter. So in whole question, you can see it is not mentioned where the water table is. It means water table is at much greater depth compared to width of the footing. And everywhere when you will see the unit weight of soil, so you can take 20, right? Okay. So we have this QU 300 kilonewton per meter square. So we can calculate QNU, net ultimate bearing capacity of soil. So that is QU minus gamma dF, 300 minus 20 into, what is the depth of foundation? 1. So we can write 280. Right. So now we can calculate net say bearing capacity, and that is QNU divided by factor of safety. Factor of safety given 2.5. You can calculate. So by calculating, you can get 112 kilonewton per meter square. Now you can check the option. That is B. Option B is correct. See this question, the ultimate bearing capacity of soil was directly given. In other cases, you will see in the other question all that ultimate bearing capacity of soil is directly not given. So in that case, what you will do? You will calculate by using Terzaghi bearing theory and Terzaghi bearing theory for the different shape. And for that, we need some more data. So that will be given in the question, right? So this value is directly given in the question. So that's why this question is very, very easy. So let's go for the next question. Two footings, one circular, another one circular and another square are founded on the surface purely cohesionless soil. The diameter of the circular footing is same at that of the side of square footing. The ratio of their ultimate bearing capacity. So see, we have to calculate the ratio ultimate, and this is very important. You will change the ratio orientation like a denominator to numerator, so the ratio will come, it will be different. You can see in the first option there is a given 3/4, in the second 4/3. So you have to be take care. So first data is given circular and then is given a square. So from the questions you can see there is a ultimate bearing capacity for square, circular to the square. So this we have to calculate, right? So for calculation of this, we have to calculate ultimate bearing capacity for circular or ultimate bearing capacity for the square. So let's do that. Suppose this is the square B into B, and this is the circular D. In the question, it is mentioned that B is equal to D. Side of a square is equal to diameter of the circular footing. So we can write ultimate bearing capacity for the square 1.3, first write the expression 1.3 C into NC plus gamma TF and Q plus 0.4 gamma B N gamma. Or similarly, we can write for ultimate bearing capacity. For the circular, we can write 1.3 C NC gamma DF NQ plus 0.3. Here it is 0.3 gamma B N gamma. So in the question it mentioned that founded on the surface, it means depth of foundation is 0. Another information also purely cohesionless, it means C is equal to 0. So these two information. So by putting the C is equal to 0, this expression will be cancelled, or we can say 0 in the both the cases. df is equal to 0, so by putting the df is equal to 0, this expression will be also 0 in the both the cases. So finally we get ultimate bearing capacity for the square 0.4 gamma Bn gamma, and for circular we get 0.3 gamma Bn gamma. In the circular, this is I have written B, so we can write D also. In the circular, we can write D also. Right? In the question is mentioned B is equal to D, so no need to be worry about it. So now we can calculate Q 0.3 gamma Bn gamma, or we can write D also. Don't be cry for that, right? Bn. So this expression will be cancelled. Finally, we will see we get 3/4. Now you can check the option. Option A is correct. If you will change the orientation, option B will come. So you have to see that also. So this question already have discussed in the first lecture also, but in the same in grade 2000, it is that same question is this. I have solved for once. That is not an issue. So are you getting my point? Okay. So next question we have. A large scale bearing capacity test on the footing size 1.05 into 1.05 meter at a depth of 1.5 meter inlay, an ultimate value 141 kilonewton. So what is the meaning of this? It means a bearing capacity test has performed on the that is 1.5 meter below the ground level, and that a square of this footing, dimension of this footing is 1.05 into 1.05, and that has bear a load, ultimate load 141 kilonewton. Good. Next, the unconfined compression test on soft saturated clay yielded a strength of 0.03 Newton per mm square. So where we are performing some test, we have performed some test that is unconfined compression test for that soil. That soil is soft saturated clay, and we got the unconfined compression stress value, that is 0.03. Okay, if the unit weight of soil is 1.6 gram per centimeter cubic centimeter, how much does the test value differ from the obtained value using the Terzaghi bearing capacity? So it means, see, from this we have performed the compression test. So from here we got some what stress will carry. So here from this stress we get some relation QU, and I'm writing QU, that is ultimate bearing capacity for this particular test, right? And from the Terzaghi bearing capacity theory also we can calculate QU, right? QU. So we have to calculate what difference we get. We will get what difference. So difference, we can write QU minus QU1. I think you got the questions, right? So first calculate what bearing capacity we got from the compression, bearing capacity test, and then we will calculate ultimate bearing capacity from the Terzaghi theory, and then we will take the difference. Are you getting my point? Okay. So see, what is the load? What load is the yielded value of one? So Q we have 141 kilonewton. So we can calculate the stress. I'm giving a name QU1, ultimate bearing capacity for the soil for this compression test, this bearing capacity test. Right? I've given this value QU1. I'm giving you a name. So 141 divided, what is the area? This would had beer from what area? So area is that 1.05 into 1.05, and this we get 120. I've calculated, so 127 point what is that? 89 kilonewton per meter square. So we got Q1. Now let's go for the Q ultimate bearing capacity. So let's see. Just write the general expression, and this is the shape of footing is square. So for the ultimate bearing capacity, in Tarjagi theory capacity, we can write for the square footing, that is 1.3 CNC plus gamma dF NQ plus 0.4 gamma B N gamma. Right. So in this question, you can see this is and the question is given soft saturated clay. Soft saturated clay, it means phi is equal to 0. Once phi is equal to 0, we have this value, bearing capacity factor, that is 5.7. We have NQ, that is 1. We have N gamma 0. So by putting the value of N gamma is equal to 0, this expression will be 0. And this is 1. We have NC, we have the depth of foundation, but we have not this value C, and unit weight of soil is given. So just convert in the single unit. So how we can get this value? C. So for the to get the value of C, we have performed some test. They have performed some test, that is unconfined compression test, that is UCT. In UCT, we have already discussed sigma is equal to 0. So by putting the sigma equal to 0 and phi equal to 0, we get some relation, that is C is equal to sigma 1 by 2 QU divided by 2. Here this Q is unconfined compressive stress. This is unconfined compressive stress, right? In the unconfined UCT test. So for this relation we can get, so that we have 0.03 Newton per mm square. So first convert this value in kilonewton per meter square. So we can convert by using this. This will become kilonewton. The bottom side, this is mm square, so we can write like this. So we got, I'm writing here, 30 divided by 2. So we get 15 kilonewton per meter square. You can check the unit conversion. So we'll get also 15 kilonewton per meter square. So now we have the C value, right, from the unconfined compression test. And gamma we can write. So gamma is given 1.6 Cg, 1.6 G by Cc, gram per centimeter cube. So we have to convert kilonewton by per meter cube. Let's see. So we have unit weight of gear. So we have to calculate unit weight in terms of kilonewton per meter cube. So let's write 1.6, and this is in Cc, the gram per centimeter cube. So first convert this gram into kg. So 10 to the power minus 3, this becomes a kg. In denominator, there is a centimeter cube. So we can write this meter cube, and this become kg. So kg we have to convert in Newton. For that, we have to multiply 9.81, that is meter per second square. So this is become Newton. This we have to be calculate into 10 to the power 9. So this become kilonewton per meter cube. So by calculating, you can get 15.696 kilonewton per meter. This gram I converted in kg first, then centimeter cube I converted in meter cube. Then by multiplying this g, small g, so it is 9.81. Because in the question it did not mention, so wherever it is not mentioned 10, so better write 9.81. And by for calculating in kilonewton, we have multiplied 10 to the power minus 3. So now we have C and this value. So 1.3 into 15 into what is NC? 5.7 into gamma, that is 15.696 into DF. What is the depth of foundation? 1.5. In the question you can see here it is given, or in 1, in Q is 1. So by calculating, you will get this value 134.696 kilonewton per meter square. See, so QU1 we get this, and QU we get this. So now we can write the difference, calculate the difference. QU1 minus QU. We get 134.694 minus 127.89. You will get 6.804 kilonewton. So see, you can get the difference of this 6.81. It means by these questions, according to this data, we can say ultimate bearing capacity by the Tajagi theory, it gets some higher value. It gets some higher value. So in this question, we will see the basic things. In this question, what is the difference here? So he has performed some bearing capacity test. From that, we get this value. Okay, and ultimate bearing capacity of shell, we get this value. But C was not given directly. C was given indirectly. To calculate the C, he has performed the some test, that is unconfined compression test, UCT. Unconfined compression test, UCT. From that, we get the C. And here the gamma was given, but gamma was given in the different unit. We have to convert in the kilonewton per meter cube. Rest are very easy. So I think this question also clear. Let's go for the next questions. So this question I would say very, very important for the GATE examination. 3 meter a square footing. So here dimension is given. Capital B is given 3 meter. Carries a gross pressure 350 kilonewton per meter square at a depth of foundation. So depth of foundation is given 1.2, and soil is given sand. So for sand, it means C is equal to 0. Okay. The saturated unit weight of sand is given 20. The unit weight of soil above the water table is given 17. A weight of soil above the 17. The Shearson parameter C is equal to 0. Okay. Sand it means C is equal to 0, and phi is 30 degree. For phi 30 degree, NQ is given and gamma is given. So determine the factor of safety with respect to shear failure for the following cases. Right. So all data we know. What is this? C is this expression, this case. Gross pressure of 350. So what is meaning of this? It means a footing that has sides 3 meter into 3 meter carry a gross pressure, can carry a load or can a pressure 350 kilonewton per square. It means it is given QS. It is given QS. And what is QS? QS is equal to QNS plus gamma DF, where the QNS is net say bearing capacity, and this is overburden pressure. And what is QN? NS? QNS is QNU divided by factor of safety. Okay, and what is QNU? That is QU minus gamma dF, right? So that we can calculate using the bearing capacity. So from here to we have to reach from here, right? These values. So let's do that. So let's do that. Okay. So let's write the general expression. So we can write general expression ultimate bearing capacity for the square footing 1.3 CNC plus gamma DF and Q plus 0.4 gamma B and gamma, right? So you can see in the question it mentioned that it's sand, it means C is equal to 0. So by putting the C is equal to 0, this expression is negligible. This expression is negligible. So general expression we can write after putting the value of C is equal to 0. We can write gamma DF and Q plus 0.4 gamma B and gamma, right? So let's calculate the ultimate bearing capacity factor of safety for the case 1. So what is case 1? You can see water table is 5 meters below the ground level. So this is the square footing. Right. And what is the depth of foundation? Depth of foundation is given 1.2 meter. And this is the width 3 meter. Water level is up to depth of 5 meter. Somewhere here. This is the water table. So you can see this is the capital B and this is the, and from bottom one you can calculate from here what is the, so 5 meter minus 1.2, what will come? It will come 3.8. So you can see this is the B and B is greater than capital B. Means when this condition is happening means there is no need, no effect of water on the bearing capacity of shell. So we can calculate in this case. So in this case you will see gamma will be, what is the unit weight of soil of the water table, that will be, this case it's 17, right? So we can write 17 into depth of foundation 1.2 into NQ is given 22 plus 0.4 into 17, B is given 3 and N gamma is given 20. So you can calculate. So I have calculated already. So I'm writing the answer. So I'm getting this value, that is 856.8 kilonewton per meter square. This is Q. So we can calculate QNU, that is QU minus gamma DF. So in here gamma is 17, gamma DF 1.2. So we can get 836.4 kilonewton per meter square. Right. So what we have to calculate? We have to calculate QNS. So what QNS will be? So QNS, we can write QNU divided by factor of safety, that is unknown. So 836 plus 4 divided by factor of safety. Right. So let's read all those things. Okay, so we have to calculate QS, that is gross pressure. So QS, we can write QNS plus gamma df. QNS we have 836.4 divided by factor of safety plus gamma df, that is 17 into 1.2 equal to, and gross pressure is given 350. So using this relation, you will see there is a one unknown factor of safety. So you will get factor of safety 2.54. Are you getting my point? 2.54. Here, whenever it will say gross pressure or total safe pressure, in that case also we can write QS. So this is given QS. So for the first case, factor of safety we get 2.54, right? Now what is the case 2? Case 2, when the water table is at 1.2 meter below the ground level. 1. Okay, so this is the depth of foundation, 1.2. This is the width, 3 meter, and water level is here. We can say water level is at the base of the footing, right? So in this case, you will see the overburden, that soil which is causing overburden pressure, that is in above the water table, and soil which is beneath the footing, that is in submerged condition. So what is meaning of this? Submerged condition. It means you will see the bearing capacity of soil. So in the third expression, that is weight of the soil which is beneath the footing, that will be in the submerged condition, but this will be in the bulk condition. So this is very important. So this is very important. So we can write for this case, we can write ultimate bearing. So what expression we have? First expression was 0. So second, gamma df and q plus 0.4 to be, this was the square, putting gamma b and gamma. So here gamma will be in bulk condition. This gamma will be in submerged condition. So 17 into 1.2 into NQ is 22 plus 0.4. This gamma in submerged condition. So submerged we can write saturated minus unit weight of water. So saturated is given 20, unit weight of water is 9.81. That is not given in the question. It means you can write 9.81. B is given 3 into N, gamma is given 20. So we'll get this value I've calculated. So it's 693.36 kilonewton per meter. So from this value we can get QNU, net ultimate, that is QU minus gamma DF. So here the gamma DF will be 693 minus, what is the gamma? 17 into 1.2. So you will get 672.96 kilonewton per meter. So by knowing this value, we can write QS, gross pressure. So that is QNS plus gamma DF. This QNS is QNU divided by factor of safety plus gamma DF. And this QNU you have calculated, what is 672.96 divided by factor of safety plus gamma 17 into 1.2, and that is given in the question 350. So in this relation you will see there is a unknown factor of safety. So we can get, solving this, that is 2.04. 2.0. So in the first part very easy, factor of safety we got 2.54. In second condition, you have to see whatever the soil which is causing the overburden pressure when the water table at the base of the footing, so that soil will cause it overburden pressure, that is in the bulk condition. 17 much there, and which is below the base of the footing, that expression third, that depends upon the soil which is beneath the footing, so that is in the submerged condition. So these two things you have to be remembered and always keep in mind. So I think this question is also clear. So let's go for the next question. So that we have a footing 2.25 meter square is located at a depth of 1.5 meter in a sand of unit weight 80 kilonewton per meter. The shear strength parameter C is equal to 0 and phi is equal to 36 degree. Calculate safe load carried by the footing against the complete shear failure. Complete shear failure. Factor of safety against shear failure is given 3. Use Tarjagi analysis, and this factor is given NC and Q and gamma. So see in this question, footing is given a square, dimension is given, depth of foundation is given. This is B is given. Sand is C is equal to 0. Unit weight of this sand is given 18. So we have to calculate the safe load. See here it is say this question is mentioned safe load. Suppose in this case it will mention total safe load. So safe load we can calculate. Safe load, it will be QNS, that is the net safe bearing capacity of shell into area of footing, right? In this case, suppose it will say total safe load. So in that case, we have to go for QS into area. So these two are very important, right? So in the question it mentions safe load. So we have to calculate this one. So for calculate this one, we have to know QNS, and for to know the QNS, we have to know QNU. Factor of safety is given, that is 3. So QNE is equal to QU minus gamma DA. So we have to calculate QU. So we have to reach from here to here, right? So let's calculate the ultimate bearing capacity. So write the general expression for the square safe of footing, that is 1.3 CNC plus a gamma DF NQ plus 0.4 gamma B N gamma, right? So now check the expression. C is equal to 0. So this expression by putting the C is equal to 0 will be 0. And from the next expression, all that are given. Okay, so directly we can calculate. What is the gamma? So gamma here it is mentioned 18 into DF. If the foundation is given 1.5, and Q is there 49 plus 0.4 into what is gamma 18. Okay, what is B? 2.25 into N gamma, that is 54. So by calculating this value, you can calculate. So I have already calculated, so that we get 2208.6 kilonewton per meter square. Right. So from here we can calculate net ultimate bearing capacity of cell, that is QU minus gamma DF minus overburden pressure. So that we get, and here the gamma 18 depth of foundation is 1.5. So we can write 2208.6 minus 18 into 1.5. We get 2181.6 kilonewton per meter square. Right. So now we can calculate QNS. QNS is QNU divided by factor of safety. So that we have 2181.6 divided by 3. And that we get 727.2 kilonewton per meter square. So don't before writing this answer, just you calculate yourself so that you will get your answer is coming the same or not. So now we have to calculate safe load so that we know QNS into area. QNS we have 7 to 7.2. What is the area? So width of foundation is 2.25 and foundation is in square inch shape. So 2.25 into 2.25, we get these values that I have written. I have calculated already 3681.45 kilo Newton. So do not confuse with this safe load and total safe load. Whenever in the question you mention total safe load means we have to go for the QH to A. When it mentions safe load, then go for the QNS into A. In the previous question, it was written gross pressure. Gross pressure or total safe load. In the both the cases, you will go for the QS. Right? So I think okay. So thank you. And in the next lecture also, I will upload some more numericals. I will discuss some more numericals, previous year gate problems from this unit, this topic, bearing capacity of shell, right? So you are doing for the gate prevision 2021. So this is this lecture for you, okay? So I will try to cover more and more chapter and more topics before the gate examination, right? And I will try to finish this soil mechanics and then we can go for the next